No. Okay, going back through. Think that brings us back.
And we're back.
Yeah, we are back.
We are.
Maybe we should just call this the technical glitch hour instead of
Goes along with the weather we've been having, so.
goes along with the weather we've been having.
That's right.
Absolutely, 100%. All right, make it this window closed, and I think we can start now. Hey, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach.
Yay!
Hey.
Astronomy Entertainment, yeah. Hey,
Yeah.
my name is Chris Kerwin. I'm the creator of the channels known as Astronomy by the Bay. I'm also an amateur astronomer and a member of RASC Canada. And
You got fireflies over your place, Chris?
there, yeah. Cool.
Lots of them.
Season. This is
Yeah.
season. Yep. I'd like to, well, I have to introduce my two regular co-hosts. Never get any other co-hosts, so anybody else wants to offer, for the
Oh,
program?
that is so funny. That's the funniest thing you said on this intro since you
Wow.
started.
It's good to know.
Unfortunately, I have to
I'll save
introduce
it for next
oh,
week. Mr. Mike Powell from the PFO Observatory is back with us this evening. Mr. Mike Powell from here.
Yay!
Hey, Mike. Hey.
Yay!
And Mr. Paul Owen from the Moonshadow Observatory in Hampton. Paul.
Nice to have you, Paul.
yeah, I've heard that before. That's what the judge said.
I'd like to welcome everybody from Facebook and YouTube land as well. Thank you so much for your support. Now, on tonight's episode of the Sunday Night Astronomy Show, we are at that point of the lunar cycle when our moon does not interfere with our view of the night sky. Clouds do, but the moon doesn't. And with the summer Milky Way about to make its reappearance, times for being comfortable under a night sky are just around the corner. Now, but what do we need to prepare for a night under the stars? Do we need special equipment? What can we enjoy with just our eyes? Well, tonight we're going to look at some stargazing tips to help you enjoy your evening. And that'll be part of tonight's presentation. Also tonight, last week, Paul covered how to capture and process star trails. And this week in part 2, Paul's going to reveal some tips and tricks on how to capture that great memory of the Milky Way. And Mike's got a map of the Milky Way we're going to show a little bit later.
Yes.
And possibly you might be able to get to just email Mike for a copy of this map. Really fantastic. All right, we're also going to have another Rosanna's Fun Fact this evening. Mike will be bringing back another vinyl bud for another great binocular target. And I'll have a quick look at some upcoming celestial events this week, just mostly about the moon, and along with your photo submissions. So let's get started with tonight's program. And part 2 of Paul's talk, we're going to start with tonight.
Okay. So before I get into presentation and slides and that, I just want to talk just a tiny little bit about the Milky Way. And we talked a little bit of last week about what it takes to figure out where it's going to be coming up, times of the year, and we see different displays of the Milky Way throughout the year. So, but coming up into, say, July, August, September is the best time of the year for the Milky Way to get it up as high as you can in the sky. So if you want to get that nice Sagittarius area down in the bottom of it. We talked a little bit about using Stellarium last week to be able to map the Milky Way to where you are and that sort of thing. There's another app you guys should look at, and I won't get into it because it'd be a talk all on its own, but it's one called Photo Pills, and you can download that. It's a chargeable app, but once you have it once, you just pay for it once, and you can use it for virtually anything. But one of our main contributors, Brad Perry, he uses it all the time, and he gets the most amazing shots over the most amazing landscapes, and it's all pre-planned. And that's really what shooting the Milky Way is all about. It's really all about planning what you're going to do and when you want to go out and do it. Really, I'll cover the ability to shoot it, and I'm going to talk tonight not so much on stacking the Milky Way, but just taking a really nice one shot of the Milky Way kind of picture to get you started. And then as you get into using your camera and a little bit of software, you can get into stacking it. I'm not going to get into that because it would make it too long. So, all right, so let's get started. I'm going to share my screen, and I'm going to show you, first of all, certainly one of the skies that our guys here likes the best. And this is from Mount Carlton, New Brunswick, which we have a star party coming up in August up there, which we do pretty much every August. And there's a spot that we always do our broadcast, here we go, our star parties from, and it's a place called Armstrong Campground. So if you go to Armstrong Campground, once you're in that little campground, there's a building there. Then there's a road that kind of drives all the way around it. It's almost like a racetrack. And you just basically walk through the woods down there, and it'll take you right down to this lake. This lake is at the bottom of one of the mountains up there that people climb. I don't know if it was Mount Carlton or the other mountain. I can't remember their names. But in any event, it's the darkest sky in New Brunswick, because when you're shooting Milky Way, you have to have a dark sky to get a shot like this. And this is just one picture. This is not a stack of anything, just one photograph. And they had just got finished putting in the new lodge that's up there. So that building there, I was a little concerned that it was going to be too bright and take away from the photo, but it actually adds to the picture. Because when you're shooting Milky Way, you're going to shoot wide field anyway. So this is not a problem. I kind of like the fact that that's in there. When you shoot the Milky Way, if you're going to shoot it over water, you want to try to get the calmest time of night that you can, because the calmer the night is, and I wouldn't suggest shooting it over an ocean because the water's always moving there. But if you can shoot it over a lake, then which is what this is, you will get really, really still water by times. And this was shot right around midnight. And usually that time of night up there, everything is just really dead still. So you can see the reflection of all the stars and the Milky Way in the water. So that's actually a shot that you should probably aspire to. You don't necessarily have to go to Mount Carlton to get it, but fortunately enough for us is when you go up there in August, the Milky Way at midnight is pretty much straight overhead. So you can get an absolutely wonderful shot like that. And if you can't get to Mount Carlton, just go on, if you download Photo Pills, just find a location that you think you might want to see it, and then put the time that you're going to be there, the date, and you'll be able to see whether the Milky Way is going to land there or not for you. Because you're not going to get this facing north. You're not going to get it facing east or west. You have to face south to be able to get this. So what you want is a lake that you can look across it to the southern horizon, and then you'll be able to get a shot like that. So that's some of the criteria. All right, so let's move on from the photo itself. So what do you need? Okay, so you need first of all, if you're going to use a DSLR, you can do them with a cell phone. Now, I won't get into that because I don't have a cell phone with the astrophotography settings on it, but they do have them, and you can get some very nice Milky Way shots with a cell phone. I will tell you this about a cell phone, though. Depending on the time of the year that you're going to shoot the Milky Way, if you're going to do it in August, like the photo I just showed you, I'll just go back right there, then you're going to want to put your cell phone on a tripod, and then you're going to want to put it in portrait mode. In other words, the tall, skinny way that you would typically hold your phone when you're looking at it, because you want to get as much of the Milky Way as possible. So when it's going straight up, you don't really necessarily care about how wide it is. It's basically the straight up. So that's what you would do there. If you're shooting it in this time of the year, May, June, and you're up at 2 o'clock in the morning and the Milky Way starts to come up, and you want to get that arch type of Milky Way that's going to go from the southern to the northern pole at a relatively low horizon, then turn your phone in the landscape mode. In other words, turn it sideways. And that's you guys pinging here. Turn it sideways, and then you'll get the Milky Way shot that way. Okay, enough about the cell phones. So yeah, so you're going to need a lens. You're going to want a wide angle lens. You'll notice that this one here is actually a 14 to 24 millimeter lens. When I shoot the Milky Way, I use this and I set it up for 14 millimeters. That'll give me the widest possible picture I want, or in August, the tallest possible picture that I want to get as much of that Milky Way in. If you happen to have a kit lens, like most of us do, if you're using a DSLR, most kit lenses are the 18 to 55 breed, and 18 is pretty much where you're going to want to set that. So the widest angle lens that you can have, even if you have a kit lens, that's absolutely wide enough to do a nice Milky Way shot. You're going to want to take your autofocus and turn it off to manual. You're going to want to turn off your stabilizer. The stabilizers are getting better on being on tripods and stuff, but a lot of the earlier versions weren't. So when you put a stabilized lens on a tripod, it kind of wants to move because it's trying to counteract shake. So sometimes the motors in there just kind of do their own thing anyway. So you want to shut that off so you have absolutely no movement when you're on the tripod, because with Milky Way, you want to get those pinpoint stars. You want a solid tripod. So this is just a little Manfrotto tripod. And believe me, it's strong enough. So a good solid tripod. If you have something with a ball head, that'll make your life easier depending on how you want to turn your camera and what angles you're trying to catch. So a little ball head is not a bad thing to have. And then of course your camera on top of that. So as you can see here with the ball head, without actually having to tilt my lens back, because the trouble with some of the tripods that you buy that you just mount the camera to the tripod, like here, they'll only go back so far, then they stop on you. Then you have to shorten a leg, or you gotta turn your camera around and all that crazy stuff. Once you've got a ball head, it won't matter. You can put that camera in any angle that you want without disturbing the solidity, the footprint that you're trying to create with your tripod. So a ball head is actually a good thing to use. And again, there's your what they would call a portrait version of the Milky Way up at Mount Carlton. Okay, if you do not have a new type of camera that has the built-in timers and intervalometers and all that stuff, then you can just buy yourself just a remote shutter. And the reason you want to use a remote shutter like this is because you don't want to take your hand and depress the shutter on the camera, because you're going to get shake, and you'll never get a good picture that way. So by using this, you're not touching the camera. When you're ready for your shot, just push the remote and it will take the photo for you. If you don't have one of those, then you can use the built-in timer that's on your camera. And most built-in timers will go to up to 30 seconds. And in most lenses, 30 seconds is too long anyway. So you've got all kinds of adjustability just by using the built-in timer if you don't have a separate remote. So basically then, if your camera will take a remote, most will, Just look for that little insignia right there. And that's just a little flap that'll open up and that will expose the hole for your remote to go in. Now, when you buy those remotes, they're not universal. You got to make sure that it will work with your camera because each cameras have different size input jacks, sometimes even different shapes. So make sure you get the right remote for the camera that you have. Now here is just the self timer. That's what this slide is designed to show you. So if you look at the back of your camera, this is a Canon camera, but Nikon, Sony, Leica, whatever you're using, they all will have a built-in timer. So you're just going to want to look for that. You don't want, well, you can use a 2-second, I guess it doesn't matter. If you're on this one, it's going to give you a 10-second time. So when you push that button, then it's going to give you, from the time you push it till the time it takes a picture is 10 seconds. If you use this one, it's 2. I would go with the 10. That will just give your camera time to settle down just in case you bumped it or you happen to be walking around the camera at the same time that you took the picture. Turn your camera to manual. So you'll see all of these settings that are there. So just take and turn your camera right to manual. That's where you want to start. Make sure that your autofocus is turned to manual. Now these would be the settings that I would start with the Milky Way if I had an 18mm lens. So I would try to start around 20 seconds. If the lens, in most cases, if you have a kit lens, it's probably going to be like f4, f3.5 or something like that. Whatever the smallest number is, use that. In this case here, the lens that I happen to have on this camera went down to f2.8. If you got one of those, that's even better. But if you don't, that's fine. And then start out right around ISO 3200 if your camera will go that high. Unless your camera is really old, you should have no trouble getting a 3200 setting. Leave your auto white balance to auto white, let it do that for you. And make sure you set your camera to RAW. The reason you want to go to RAW is you're going to be dealing with one picture based on what I'm telling you here. And so you're going to want to be able to edit that photo to the maximum that you can edit a photo. And if you shoot JPEGs, you're not getting enough freedom to edit as you would if you shoot RAW. So make sure you shoot RAW when you're shooting those photos. So how do you set it up for focus? It's really quite simple. So on the back of cameras, they will have that little magnifying glass that when you're looking at your photo, you can zoom in and zoom in again. But that works for your live view. So if you're using your back of your screen to frame up a shot or something like that, this is what you're going to do is you're going to point it to the brightest thing that you see in the sky, which could be a planet, could be a star. It doesn't matter so long as it's bright because they're all going to be very small in relation to this. And then you're going to take your lens and then you're going to actually, before you even do that, you're going to put on your heater. And we'll talk about that after. I'll show you that in a minute. But you're going to get a heater band or a hand warmer, which you're going to put on your lens. Once that's on the lens, then you'll do this focus routine. So you're just going to pick the brightest thing you see in the sky. You're going to focus it the best that you possibly can until that is as small as you can think that it is. Then you're going to magnify it 5 times. And then you're going to do the same thing. You're going to do what we call racking in and racking out. And all that simply means is you're going to spin that lens until you get that thing as small as possible. Keep turning it till it starts to open up again. Once it starts to open up again, then go in reverse. Get it to as small as it possibly can until it goes as small as it can, and then keep going until it starts to get bigger, and then go again the opposite way. And that's called racking. And once you do that a few times, you'll find the smallest place that you will get for your star. And then once you're done that, just go ahead and press that magnifying glass one more time. That puts you into 10 times, and you can fine tune and really get it all nailed down. Once you've got that done, then you don't have to touch it for the rest of the night. I think, okay. So if you have a lens that you're using for this, a 50mm lens is probably a little wide for a Milky Way, but you will still be able to get a picture of it. But this is what they call the 500 rule. And what this rule is designed to do is to take the focal length of your lens, and then you divide it by 500. So if I had, say, a 50mm lens, if I divide it by 500, I should get 10. Oh, and actually, there's an example here. For example, when using this lens with a focal length of 24 millimeters, you would divide 500 by 24, and that gives you 21, or a shutter speed of 21 seconds. So that's basically telling you that based on your focal length and based on this 500 rule, this should give you relatively sharp stars. So what you're going to do is take a photo. Once you've got this figured out, you can say, okay, 21 seconds, and then play that photo back and then blow it right up and see, okay, are my stars pinpoint or do they look a little bloated? If they look a little bloated, then you want to shorten your time. At this point, if you're using the timer in your camera, it's going to go in 5-second increments, unless you have some of the newer cameras, and you can do it by 1 second. But typically 5-second increments. So what you'll do is you're going to take that 21 seconds and then take it back, if I had the 5-second rule, back to 16 seconds. So and then I'll take a picture at 16 seconds. Do I have a sharp picture? Yes, I do. Are my stars round? Yes, they are. Okay, so now I know that's the focus point that I'm going to use to shoot my Milky Way, and I'm comfortable knowing that with 16 seconds I'm going to get nice round stars. Okay, so so the 500 rule also is just a basic. Don't use that as the gospel. Just use that to get you started, and then from there you may have to adjust it a little bit. Now, for those who are using a crop sensor camera, not a full frame, you have to factor in the crop factor of your camera. So how do you do that? So it's pretty simple. You take 500, divide it by 1.6 crop factor, if that's what your crop factor is. On the Canons, it's 1.6. On the Nikons, 1.5. I'm not sure on the other ones. But anyway, you just take in that crop factor, whatever your crop factor is. And then once you get that figured out, then times it by the focal length of your lens, and then you'll get that. So they're showing you an example. So if I had a crop factor or a crop size lens, I would take 500 divided by 1.6, and then I would times that by 50, and that gives me 6 seconds. So that tells me the crop sensor lens and a 50 millimeter crop sensor and a 50 millimeter lens, 6 seconds is what I should probably end up with for a shot. So so those are really, really good starting points. And I could show you how to edit one, but I'm not going to do that. So other than that, those are the things that I would recommend that you do for your Milky Way. And just like when we talked last week about the star trails, make sure that you dress warm, because it will be cold at night, regardless if you're in the middle of summer or not. Make sure that you take some bug spray, because that time of the year, there are some bugs out there. Make sure you got extra batteries, and the batteries you do have are charged. And make sure you carry an extra SD card, because your memory cards can fail, or your card could be full and you don't want to get rid of Uncle Joe's birthday picture. So make sure you got lots of memory there. Other than that, that is just a really short, simple way of taking a shot of the Milky Way with one photograph. And like I say, the editing we can talk about on another time. So other than that, I think that is it. There.
Okay, anybody have any questions for Paul?
Can't wait to get out there.
Yeah. All we need is clear sky.
Yeah.
I don't even hear.
When I was on vacation in Ontario, I never got an actual clear night to go out. It would have been nice to see the Milky Way over Lake Simcoe, which would have been beautiful.
Yeah.
Wow. Is it pretty dark there, Mike?
It is up where he is on that side of the lake, yeah.
Wow. Nice.
Yeah, I'm going to hold my talk for next week, because it's going to be about 30 minutes. So, I'm going to get Mike, though. Mike's going to share some images, though.
Oh, I was going to.
Milky
Did you want
Way.
Vinyl Bud or the image first? Doesn't matter.
Well, just bring up the image first, and then we'll go to Vinyl Bud after we're done with this part of the talk.
What was that? Let's go full screen there, and then do this and this. So I'd like to share this. If it comes up on the screen, it should. Can you see my Milky Way there?
Yep.
So a few years back, I got this email from a fella, and I can't even remember who he is, but he was saying, would you be interested in some large format files of the Milky Way with all the Messiers that you could print off into a 6 foot by 3 foot poster, have plasticized, and then stick it on the wall of your observatory. And I went, sure. And he sent me like all of these files. And man, this is the coolest thing. Like I said, you can zoom in at least 300 times. There's 300, and everything is still pretty much crystal clear, as you can see. And just in around Leo, I mean, all the Messiers are marked on it. And this particular one, they're marked in red. You come over around in through the Milky Way area. The Milky Way is highlighted in blue, but all the Messiers are marked off in red. And it's the whole night sky from one side to the other, every constellation, the full year's worth. And you can actually print them off into a 3 foot wide by 6 foot long poster. And I used them actually I had mine plasticized and stuck on the wall in the observatory. And when I found the Messier, I just made the red dot into a green dot. And that way I knew I had it. And that was one of the ways I was keeping a record of doing it. But if I've got them in various colors, where else did I? Oh, because it's on the same screen. Hold on here. See if I can. Well, all right. There's one with a black and blue Messiers with a white, or a whiter Milky Way, black and white. There's one that's the opposite. It's white with red Messiers and a gray Milky Way. And then here's another one with like a greenish Milky Way, and then all the constellations, and no color at all to the Messiers. They're just the dots marked at where they're at. But
Nice.
if anybody is interested in one of these files, you can email me at pfoobservatory@gmail.com, and they're only 1.6 megabyte in size. I'll gladly send them to you if you want to, take them, print them off, go to Staples, have them printed off into a nice chart, and you can hang it on your wall or hang it on your observatory wall if you have one. So
That's nice, Mike.
Yeah.
Yeah.
Yeah. So if you look, Mike, can you zoom in to the Sagittarius part of that Milky Way? Yeah, right there's good. So when you're shooting up at the Mount Carlton, you'll see that little teapot. You can see that as plain as the nose in your face. But all those little things that are up there that Mike talked about, all those Messier objects, if you happen to have a telescope, a lot of those you can actually see right up there, just coming off the teapot. And there's nebula in there, and there's clusters, there's star clouds, there's all kinds of dark nebula. There's so much stuff in there.
Oh, that's a busy spot in the sky. Yeah.
Yeah, that thing is amazing. But that chart will show you everything that's in there in the Messiers. Plus, you get able to see the constellations, the asterisms of the constellations, so you know in the sky where to look. So
Where the spout is on the teapot. Oh, sorry. Where the spout is on the teapot, just the one to the top right of that, that square to the top right would be the center of the Milky Way.
Yeah.
Here in that area. Yeah.
And then you also, when you look up at night, you see that big rift in around Cygnus.
Yeah.
There it is.
Yeah.
In the dust cloud. But then your winter Milky Way is over here, right? You got Orion and Auriga and the twins, and that's your winter Milky Way there. So it's the whole sky from one side to the other, every constellation and every Messier object. So
that's fantastic.
So if anybody would like a copy of that, pfoobservatory@gmail.com.
Yeah.
Awesome. Great. Thanks, Mike.
No problem.
To get one of those copies behind me someday.
They're cool to have. They really
Yeah.
are.
Yeah. How big did you say they were? 6x3?
You can print it off and get a nice
6
foot by 3 foot. Yeah.
Oh, wow. That's huge. That's beautiful.
Fits one wall in my observatory perfectly.
Yeah. All right, let's go with the Vinyl Bud maybe next.
Probably what? Where's the share button here? What? Am I still sharing? No. Oh no, there's workspace. Okay. Vinyl Bud screen. Ooh. Here we go. Should be coming up.
There it is.
Yep, there it is.
This week my Vinyl Bud is, and it's actually two. You get the Crow's Arrow and the Stargate. Dun, dun, dun. Remember Stargate?
Oh, yeah.
So, being southwest of the Sombrero Galaxy are the Stargate and the Crow's Arrow asterisms. The Stargate is a nod to the popular television series, and the Crow's Arrow is shooting right towards it. The Stargate and Crow Arrow can be observed in small telescopes and in binoculars. So it's a pretty good object. How would I find it in the sky? Well, tonight, if you wait until 10 o'clock and it was dark and clear, orient yourself due south, 180 degrees due south, look up, and you're going to see, is it Corvus? The
Corvus, yeah.
constellation, Virgo, and over here, I can't make that one, but Crater or Carter. And in between those three, if you just do a triangle between them, right in the center, right dead center, you'll find it right in here. So it's really not that hard to find. Just go due south and look up, and as you go through Corvus, you'll find it. What does it look like? Well, over here in the corner, you see that's where the Stargate is, right? The very, very point where the arrow is actually hitting, and then the arrow comes down like this. That's why they call it the arrow. If you were to photograph it, there's the arrow coming down and then splits on each side. 10 by 50 binoculars, big enough target. You can look up, and like I said, the arrow is actually shooting right into the Stargate. So it's kind of cool to get two asterisms in the same field of view. Compared to the full moon, got to be at least 4 full moons across. So large target, nice in the sky. You'll see the bright stars because that arrow stands out right out on you. And if you use a small telescope and zoom in, I guess the Stargate is pretty cool to look at as well. But it's not, the Stargate just basically is at the end of the arrow. And are you ready for this one? What's the difference between an astronaut and a cosmonaut? Astronauts take it slow and easy, but cosmonauts are always rushing.
Oh!
That's what I get of the week. Bye, Bono Bun.
Oh, man.
Keep that up, Mike, or we're going to lose the rest of our audience.
Hey, I like that one. That was a good one.
Well, that was Putin you in your place. All right, that was really good.
Putting you in your place, yeah.
Oh, man.
I'm going to say hello to my brother Danny, who looks forward to your final jokes every week.
Danny.
Hey, Dan.
I'm glad somebody likes them.
Yeah.
That's the reason I do them.
He lets me know every week. That one what Mike said this week. All right. Let's go from there to we got a Rosanna's fun fact ready to go, Paul? Or
I do.
Okay.
Believe it or not.
We're going to be a little bit early tonight, but that's just because I didn't want to try to squeeze in my whole talk tonight.
All right. You all set?
For next week. Got a show for next week already. Here we go.
All right. Here we go.
Rosanna's Fun Fact.
Well, welcome back, Rosanna, for another fun fact. We missed you last week, and so we're doubly excited to have you this week. So let's get right into it. So Rosanna writes, "Hi, Paul. This week, as a part of Game Week for my students, we played songs on weird settings on my other keyboards. This resulted in pieces sounding like Star Wars fights with lasers and lightsabers, pew, pew, and pinging all over the room. But do lasers actually make a sound? Well, let's find out. Let me get up our picture here. There we go. Oh, no, it came twice. So, according to Gizmodo.com, powerful lasers do make sounds, but they're not pew, and they don't come from the light itself. Instead, the noise comes from the equipment that generates the laser light, or the interaction between a laser beam and an object. So I wonder what sound, if any, the equipment made during this recent laser event. Now, on April 26, 27, a 2-day experiment was run by the Deep Space Exploration Laboratory, or the DSEL, using a Tiandu-1 satellite, one of 3 spacecraft launched in March 2024 to lay the groundwork for an Earth-Moon communication and navigation network. Now, the China's Deep Space Exploration Laboratory, the DSEL, working with Yuanan observatories during a 2-day experiment, achieved something previously thought impossible. A laser was fired from 1.2 meter telescope equipped with a newly upgraded near-infrared system. It hit the Tiandu-1 satellite 130 kilometers from Earth and returned a clean signal. I was going to say spignal, just hang on. I'm going to make this wide so I can read all of it. There we go. There we go. And it returned a clear signal despite intense color despite intense solar background noise. Until now, such experiments could only be performed at night due to the sunlight overwhelming the laser return. The first ever feat of measurement was accomplished with a satellite called the DRA, the Tiandu 1, located about 130,000 kilometers away. This was possible due to a special reflector on the satellite and a powerful 1.2 meter telescope on the Earth. The moon is approximately, on average, I think it was 130,000 kilometers away from Earth. Or is that 220,000? Anyway, I'm not sure on kilometers.
400,000 kilometers away.
So yeah, 220,000 miles.
Yeah.
Yeah. And away from the Earth. So Tiandu 1 has an irregular orbit around the moon. Its distance to the surface varies, but it maintains a steady 200 kilometer separation from its sister satellite, Tiandu 2, which is also in moon orbit. Now, the laser feet from Earth to satellite and the return to in daylight hours is comparable to hitting a single human hair 10 kilometers away. That's pretty impressive. So besides the first ever satellite bounce measurements in daylight, why is this a big deal? Satellite laser ranging is the gold standard for pinpointing orbits. Ground stations fire nanosecond pulses, which bounce off of retroreflectors on a spacecraft and return to reveal distance down to centimeters. This technique is routine for low Earth satellites, even in daylight, but glaring solar background noise has so far limited Earth to moon or satellites in a moon orbit shots to nighttime windows. Achieving that kind of accuracy in daylight means China can gather orbitable data anytime the Tiandu 1 passes within view, multiplying the number of usable measurements and improving long baseline positioning. This feat also is a huge factor in cementing China's goal of putting astronauts on the moon by 2030. What kind of sound that laser made, in any, is up to anyone's wild imagination. Now, 2 weeks ago, the Fun Fact discussed Vera C. Rubin's work and proof of dark matter existing within galaxies. But back in 2018, NASA Hubble mission scientists published an article about an oddball galaxy that was lacking in dark matter. Now, this is the Hubble's view of the ghostly galaxy lacking dark matter. This large fuzzy-looking galaxy is so diffuse that astronomers call it a see-through galaxy because they can clearly see the distant galaxies behind it. The ghostly object is cataloged as NGC 1052 DF2. On April 25th of this year, astronomers stumbled upon yet another ghostly galaxy that appears to be devoid of dark matter. So discovering a galaxy without dark matter is indeed perplexing, like finding a shadow without a source. Yet over the past decade, several such sightings have been reported, all of them so-called ultra-diffuse galaxies, which are about the size of our own Milky Way, but remarkably sparse in stars. The latest member of this puzzling collection, known as FCC 224, resides on the fringes of the Formax cluster, a collection of galaxies that lies roughly 65 million light years from Earth. First spotted in 2024. This is a pseudo-colored image of the ultra-diffuse galaxy FCC 224 as captured by the Hubble Space Telescope. FCC 224 is a dwarf galaxy that boasts a dozen luminous, tightly bound clusters of stars, an unusually rich population for its size, typically seen in larger dark matter-rich galaxies, yet appears to lack the mysterious substance. It also occupies a distinctly different cosmic neighborhood than the other galaxies that are deficient in dark matter, suggesting such objects might not be isolated flukes, but rather represent a more common, previously unrecognized class of dwarf galaxies, according to two complementary papers published last month. And the best part is, no existing galaxy formation model within our standard cosmological paradigm can currently explain how this galaxy came to be, states Maria Buzzo, a doctoral candidate in the astrophysics of Swinburne University of Technology in Australia, who led one of the new studies. So, astronomers now have yet another galactical mystery to solve. Every day, our world has a little and sometimes big surprises for us, alter our thinking patterns, or take an accepted view of a well-known item and change it. Like this absolutely, there we go, let me just make that, there we go. Like this absolutely older but adorable possum gravity potato. I will never think of planet Earth exactly the same way as before. So what is the possum gravity potato? The gravity on Earth is not the same all over. In Potsdam, Germany, data from the orbiting satellites Grace and Champ were used to create a gravity map of the Earth. Blue areas are low gravity, red are high. Scientists do not yet know all the causes for the varying levels of gravity. Why a potato? Because scientists have a sense of humor. Love naming things, and it looks like a potato. So, whoops, I just lost it. Give me a second. Where'd it go? Hold on, I gotta finish up here. So, how to name a volcano. Global Volcano Database, add your name. Or just let the cat walk across it. And there's the volcano's name. If you can pronounce that, there you go. And that's this week's
Rosanna's Fun Fact.
Oh man, she always has something so interesting. Yeah, I'll never look at a potato the same way.
You're muted, Chris.
Yeah, I mute myself so I don't cough. And there we go. Yeah,
There you
the she comes up with is unbelievable. And there's some really kind of neat stuff coming out of the web right now as well. Webb apparently spotted a galaxy that is almost in complete formation only 300 million years after the Big Bang, which should not be happening. And they're even tying into the expansion of the universe, like how we picture the universe as expanding and accelerating as it gets farther out, right? Which is supposed to cause dark energy is supposed to be that cause. But they're talking about the voids that are between us, like our galaxy and Andromeda. There's a large void, there's a large space between us. And those spaces are increasing as well. So when we're saying a galaxy is moving at a certain speed away from us, is it because of the size of the voids is increasing, or is it actually the galaxy itself that's moving that quickly?
Well, that's interesting because they say that over time that our two galaxies are going to collide.
Yeah.
So if we're moving apart, how can that be?
Yeah. Or I guess we're close enough. I don't know. But yeah, that's another 4 billion years apparently. Yeah. So is the void on that side pushing back? Anyway, I think Webb's going to reveal an awful lot.
Because up until that point, until the web came, we only knew what we knew. But now with that new information that we're getting back, now we're starting to probably rethink a lot of things, right?
Now those reflectors, that's great. Of course, we come out. Retro reflectors really started when we were back on landing on the moon, right? Because they left some behind, so we could measure the exact distance to the moon within a centimeter. And now with that, they're putting them on satellites. I wasn't aware they were doing that, but that's interesting. So you can find the exact distance to a satellite as well. So that's pretty cool. Yeah,
that's the cool thing about astronomy is there's nothing. Everything's theory. No matter how much we think we know, there's still a lot of theory involved with it, because until you can get the actual data and say yes, this is now proven. A lot of it's theory based. So
Actually, I just read an article that think that our universe is spinning.
Yeah. So we're inside a black hole,
causing things to move away at a higher speed. Like if you have a tire, right?
Yeah.
The center of the tire's moving this fast, but the outside of the tire's moving that fast to keep for the same rate.
which theoretically puts us inside a black hole.
Well, the other thing is
the whole universe.
where's the center of our universe? If everything's expanding away, then there has to be a center point somewhere.
We're the center of the universe, right?
Yeah.
Is that center void of stars? Right?
Yeah.
things to make you go,
Yeah. Oh my gosh, it's crazy. It's crazy. All good stuff though.
Like you say, you come up with any theory until they prove you wrong. You're right.
That's right.
There's
That's
a
right.
fella, and this one fascinated me. This fella, he actually won a big debate over in Europe, and the question was, is gravity a push or a pull? And he said gravity is a push. And every argument that they had that gravity was a pull, he could prove saying gravity was a push.
That'd be an interesting thing to see what his theory is on that.
Same theory that gravity is a pull, only the opposite.
Yeah.
But yeah, it's just cool. Like he turned everything around and went, and he won the debate, which is the surprising part.
Yeah. Interesting.
Yeah, very. Okay, let's get to some photos. I got a few here to share. Excuse me.
Who's been taking photos? Unless we got clouds.
Yeah, really. You got lots of pictures of clouds, I hope.
Lots of cloud photos.
Reprocessed, yeah. There are some reprocessed ones here. Let's take a look here. Now we got some here from Francois Theriault, first of all.
Oh, wow. Yes, sir.
This is Clamshell Nebula.
I've never seen that one.
No, I haven't either. And
You
it's got
almost want to put on a pair of 3D glasses to look at that one. That's cool.
That's pretty cool. Yeah. Yeah.
He didn't include data this week. He just included the photos themselves. But
Into the dark matter. Wow.
there's another. This is a detailed view of that same nebula.
Or dark. Sorry, dust.
Yeah.
I love the
It
dust.
must be a relatively faint nebula, I would think.
Look at where it is, Paul.
Guess where it is?
Yeah, right in Cygnus. I've never seen it.
We'll find that.
Yeah, I'll have to look for that one.
Bet
Does
you
he
it's
give
in a handpad.
Does he talk about it?
No, he doesn't. He just sent me these through the Gmail
Oh, okay.
account. So he just said, "Here's some pictures that you can put up."
Very cool.
But I think if you go to his Facebook page, Francois Theriault, you'll find his. I think it's actually on the Future Astronomy Club too, as well.
Yeah.
He puts
No.
photos up there.
Nice image.
Yeah. And here's another one from the Pelican Nebula. Yes.
Oh yeah. Who doesn't love the Pelican, eh?
Hmm.
A lot of people can't see it.
I can't right at the moment either.
It's actually in between. There's that spot, and then if you go all the way to the top, you're going to see two bright stars right in the center.
Right at the top.
Yeah, one there. Yeah, there you go.
Yeah.
No, I'm just kidding. That big black spot there, just down below your arrow. The big black. Just take your. There's a great big black spot. No, up. No, up to your
Oh.
right.
That one.
And then up, no,
That one.
up there.
There.
That's
Okay.
that's one of the offset eyes of the Pelican.
Okay.
And then the bright star is the other offset eye, the brightest star you were on a second ago. So
Okay.
if those two eyes, and you look at that, take your arrow to the left, and it's a very long bill, like a big long beak, and it curls down almost like
Oh, here. Yeah. Here.
yeah. So there, and then the head is the opposite side, so it's got a very long forehead on it.
Okay. Sure.
Yeah, that's the Pelican.
Yeah. I'm sure it is.
I know
Right
you can't.
Right after I leave the drugstore. Cannabis NB. There's where you find that.
Yep.
That shot comes with your purchase of Cannabis NB. Okay, here's another shot of the Seagull Nebula. Now, that kind of looks like a seagull, I guess.
Yeah,
Maybe that's his head, and that might be his body. I don't know.
yeah.
There's another one. Nicely
Yeah,
done.
Nice shots.
Yeah.
Yeah, incredible. Thanks, Francois. Keep them coming.
Yes.
All right, Ken Muscola sent this in. He said, "Hello, Chris. Yet another image from the C-Star S50. Hard to pick favorites, but this grouping of galaxies is in Canis Venatici. Hope we get the right picture here. M106. Am I on the right?
Yep.
Yeah, 106. NGC 4248 and nearby pair NGC 4231 and 4232, as well as NGC 4217, 62 million light years away. And last but not least, NGC 4226 are some of my favorites." I said imaging time was 34 minutes, consisting of 206 10-second exposures using Cyril and Graxpert with this quick stretch to reveal very distinct shaped galaxies with the everyday amateur astronomer's reach.
Yeah.
I hope viewers might enjoy this detail. We sure do. Thanks,
Well,
Ken.
very nice.
Amazing how many galaxies are out there.
Oh my goodness.
And he sent this one as well. He said, sorry if there's enough time. Here's the last one from last night. He said, just like to point out Copeland's eyes, NGC 4435. I'm going to get them up here. There they are. And NGC 4438. Once you see them, you can't unsee them, he says. So 4435 and 4438 right there.
Mm-hmm.
Yeah.
Another pair right above them, right?
Yeah.
So
Nice.
cool.
Thanks, Ken.
How many galaxies?
From Mark Pitkin here. Mark gives us this one of M81. M81, M82, of course.
Yep.
So it's C-Star S30. Yeah. And nice capture of him. This one here is actually, this is a snip of it. So
That's nice. Oh, look at that. Nice
13.
cluster.
M13, where it's located along near NGC 6207, IC 4612, and then M13. Berkeley Columbia cluster, beautiful cluster.
Yeah, crazy.
And then he's got this one, NGC 4631.
There's two of them. There's a hockey stick down there too.
There's NGC 4657.
Yep. And the whale.
Whale galaxy, yeah.
Yep. Very nice.
It's a whale of a galaxy.
Yeah. I think that's all I got for this week, actually. If you have any photos. Look, I mean, we've had a cloudy week, so we really haven't had much opportunity for anybody to
Yeah,
get
but
in.
look at these three handsome dudes.
Oh, absolutely.
2.5.
Really, you can look at that for hours.
Oh, these three over here, you mean? These guys over here.
No, the ones in the back.
Oh, yeah, that's what I meant. Yeah.
I don't know who the aliens are in the front, but
If you have any photos, we love getting them. We love sharing them. So you can send them into astronomybythebay@gmail.com, and we'll be happy to put them up at the next broadcast. Just a couple of points of what I'm looking at this week. First of all, on Monday night, the old moon, or Monday morning, actually, tomorrow morning, the old moon challenge, which means that we have a very thin moon, less than 1%, about 23 and a half hours before new moon, so very close to new moon. Moon rises at actually 4:48 Atlantic time. Sun rises at 5:42. So you may say, well, I got an hour there. Well, you really don't, because the sky starts brightening up a lot when the sun comes up. So you might be able to catch that one. So this is looking east at 5:15 a.m. Tomorrow morning, Atlantic time. So
which that'll be a challenge. What does it say? What how high on the horizon it is?
At that time?
Yeah.
That time there? No, it was about 10 degrees, I think.
Okay. So you'd have to have a fairly low horizon to be able to see it.
Yeah. Like maybe someplace like Martello Tower and looking down towards Partridge Island. Kind of shot.
Would you see it at St. Trest, I wonder?
I don't think so. Don't know if you're high enough. This is looking east.
Oh, it's east. Okay, yeah.
Rest. Excuse me. Okay. Also, this week, of course, right after the shot like that, you've got the new moon. It actually happens at midnight, 2 minutes after midnight on the 27th. So the new moon, of course, is when the moon is between us and the sun. Not directly between, of course, because we don't have an eclipse, but we can occasionally when the moon is in the right position away from us. But it's actually a perigee moon, so it is the larger moon. If it was in line with the sun, we would have an eclipse. But perigee means that it's a super moon. It's a super new moon, right in this case. So we're going to have larger tides than normal over the next few days. So keep an eye out for that. Following up on that one, we've got this one on Tuesday night. So just after the new moon on early Tuesday morning, 2 minutes after midnight, look to the northwest in the evening sky, and you should be able to find Jupiter and a very thin crescent moon again. This is now another new moon challenge, so it's about a 1% moon, a little bit less than 1%, I guess. 22 and a half hours old at moon set. So if you can catch it on a 20-hour moon, you're doing really well. New moon is at 12:02 a.m. and sunset is at 9 p.m. and moonset is at 10:25. Again, it seems like a long time between sunset and moonset, but by the time the sky starts to darken enough to catch that moon, it's pretty well close to the horizon. So another good challenge. If you're looking for it, you can try to look 10 degrees to the lower right of Jupiter. That's where it should be sitting. So this is looking northwest at around 9:30 Atlantic time Tuesday night. So good luck with that one. If you get any photos of that, send them in. We'd love to see those. I'm going to mention this quickly because we do have a spring, our star parties are starting up actually. Next weekend is the first one.
Yeah.
Wow. So the Coojabquack Spring Star Fest, the Mount Carlton Star Party, Fundy Park Stargaze, and Coojabquack Fall Star Fest. So we have two Cooch, one at Mount Carlton, one at Fundy. Of course, these are the dark sky preserves in the province. And as members of the RASC Canada, we help to support their dark sky initiatives by setting up our telescopes for the public at these locations. So all we do is we go there for the weekend. We set up our telescopes, and the public is invited in as long as you pay for your admission. In some cases, it's just the admission to the park. Other cases, it is, you're actually paying for a campsite. We are there Friday evening. We set up Friday evening, so we're there all Friday evening right into Saturday morning. Saturday all day, we usually have a telescope clinic, so you can bring a telescope along if you have any trouble with it. Bring along your camera. We'll show you how to take some Milky Way shots. Also, we do solar observing all day Saturday. Saturday evening, we have a second night of observing, and again, we're out looking at the night sky. We always pick these on nights when we don't have any moon to deal with. That's why the dates are kind of odd, maybe. We don't have our Fundy Park Stargaze on Labor Day weekend this year. It's on August 22nd, 23rd, because that's when right around the new moon part. So we want to be there when there is no moon, so we don't have all this artificial light pollution out there. But anyway, the first one is Coojabquack Spring Star Fest. Here's the notes from the webpage. My members, the Royal Astronomy site for our annual Spring Star Fest. Several telescopes we have set up on Friday and Saturday nights, and that's all the blah blah blah. Preceding the session, we'll have a little presentation at the outdoor theater where you can learn about what we're going to look at. And for visitors, there's information there about them, and also the schedule. What's up? Night sky viewing, solar observing on Saturday, telescope clinic, another what's up presentation on the second night. And again, with night sky observing, and then we leave on Sunday. So there's nothing happening on Sunday. And here's the observing site for Cooch. It's at observing site number 94. That's where, is that 94? Yeah, I think I can see that. No, 194, sorry. Observing site number 194. So that's where the telescopes will be. But astronomers will be, so you can set up anywhere near that and come over and join the crowd. And if you want more information about star parties, just go here, RASCNB/star parties, and we have all the star parties listed there and what they're all about. So try to take them in. If you get a chance to take in at least one of them this year, they are a great experience. You get an opportunity to kind of kick the tires, I'll say, to see what telescopes are out there. Maybe you're looking at purchasing a telescope. You can talk to the astronomers. They love to talk about their gear. So talk to them before you make a purchase. That's always a good thing. And get a look through that particular telescope and see exactly what you will see if you do purchase something like that. There'll be some sea stars out there as well, some more compact telescopes, so you can get to talk to people about that as well. And they're always a great event. It gives us a chance as amateur astronomers to get together from around the province for these events.
And all that information is on the St. John Astronomy Club website as well.
There as well, yes, St. John Astronomy Club website as well. And that's just sjastronomy.ca. Okay, so that's the events for the star parties. Here's our list from Lisa's Lookup, Astronomy and More. Now, Lisa puts out a great Facebook page and Instagram and all these other ones. This is the event that she puts out for the month of May. So here she has the events themselves. This is the date of the event, the peak times, when's the best time to see them, and what you need for seeing tools, naked eye, binoculars, or a telescope. You can find this chart downloaded at Ruby Moonbeams on Instagram, Mastodon, Facebook, Threads, and now on Blue Sky. Thank you, Lisa. And finally, we're going to end up with the calendar here from Kurt Nason, who puts this six-week calendar together for us all the time. And here we are for May and June, right into the first 2 weeks of June. And we can see here's the Cooch Star Party that we talked about Friday and Saturday night of next weekend. A new moon and where the moon is going to be on those few days. So you can find that calendar too at sjastronomy.ca. And that should be it for photos and all that kind of stuff, I think. You just close that one out, and I'm going to close this one out. And one more over here. And I think I can go to this now. Maybe come here. All right, so I guess that's it, guys.
I would say.
For this evening, we're going to carry over my talk for a third week now.
You know, when you retire, you tend to push things off.
You do.
So
yeah. Oh, I know.
I think you're starting to fit in very nicely.
All right. Well, so yeah, I mean, we got time before we need to talk about summer stargazing tips anyway, because it doesn't look like summer out there right yet for us locally anyway. But hopefully soon. We're all keeping our fingers crossed for the weather here. Tuesday, Wednesday, Thursday, I think might be clear nights. Those few nights, so fingers crossed for that. So anyway, that's our show for this evening, everybody. I hope you enjoyed the program tonight. Special thanks again goes out to Rosanna for another interesting fun fact. And awesome, Rosanna, thank you very much. Special thanks too goes out to all of you who share our program through Facebook and YouTube. We really do appreciate it. Remember too, we do love getting your photos, so send them into astronomybythebay@gmail.com and we'll be happy to put them up on the next broadcast. Just reading a couple of comments here. Found you dudes just in time. I'm about to take out the scope for tonight and still Rusty looking forward to some tips. There you go, Reed. So we'll be back again next week for sure. So until next week though, wishing you clear skies. And as we'd like to say, guys, open your eyes to view the skies and keep your scopes, everybody, pointed up. Good night, everyone.
Beep, 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 beep.
Oh, yeah.